analysis, or someone has attempted to make some analysis on mRNA, SP1 mRNA, but at the end of the history, the surviving DNA in data box, and in terms of concept is transcription. The other is data box similar to the other. You can see the dynamics that remain at the end of the binding protein, that is acting enzyme, the RNA and the DNA. In this way, one can have the fragment of information that can be used for generate association with advanced machine learning method. Okay, this lesson I show some applications that I show the more recent that you have. In particular, this one, you can see there is text mining for improved exposure assessment. That could be a good point of, would be a good starting point to go on the development of more efficient tools for text mining. Technology discovery in the text is more complex than if you use e-commerce or industrial data. The problem is the linguistic. At the moment, the semantic level or how to automatize the generation of semantic using linguistic data is quite complicated. Or if there are some tools, these tools are automatically copyrighted and are used, for instance, for strategic use, such as intelligence or other. We cannot know if there are, but at the moment for biomedical field, for molecular biology, many simple text mining tools are embedded to support the search of sequence of information, but not directly to give some association of the data or generate some rules. This is I think this is a challenge. I guess a challenge for the next years, because then the problem is not only computer scientists, but merging linguistic and humanities and computer scientists, because the the process in which we create a concept that can be transferred in a formal way in a machine learning and data mining must be after tested on real human data that are the text. This is the protein, the other structure are quantitative, are generated by instruments. But the text on which you work and on which you prepare and plan your experiment are of this time. Many papers are very complicated to extract the knowledge of a paper, the results of what you want. Then the idea to use this text mining for different pre-processing of the data. In fact, you can consider it as a system to extract and transform the data for the other. The transformation is quite well standardized. Until the syntactic level is not, there is many tools that perform these tasks. But the semantics remain a big problem. It's a problem for machine learning, it's a problem for linguistics, it's a problem. The general. Other things are that I suggest you to test, for instance, Arrowsmith. That is a good attempt to bridge different concepts or different query in a database, because I guess at the moment one of the best solution. The other many tools are not yet available because the the text mining project seems to be in a decay phase, but because the many support tools support database are not yet available. One can click on the site or check the site also if published in a paper that the website doesn't work, then one cannot access to additional information. Then the idea is to start anything, to take the data and to try new tools that possibly perform better than this one. Then it's very, very complicated. I guess to explain in a very raw way, because for each slides of the named entity and other we need a lesson only for one slide. But I would like to give you what is one of the kind of information that are necessary to improve machine learning methods. Fuzzy set. In this case, the use of fuzzy set or value set, or what is a sort of soft set, is absolutely necessary to perform not the basic clustering, but to perform the association among the fragment of information about the element that we are using. The other problem is the verbs, and are essentially linguistic problem, because in the case non-inhibit. You have inhibit. You don't have non. Officially is non-inhibit from a positive meaning, assume a negative meaning. Then the context in which some words are embedded is another question to solve. The last thing is the creation of specific vocabulary that are for cancer, that are for PubMed, and this vocabulary that are annotated, that are controlled vocabulary, such as mesh terms, for instance, is a good starting point to develop tools for data mining or literature-based discovery, because they have controlled. Otherwise, we can start from a simple query given by user in a database. Anything can be retrieved, even if not related to the query submitted. The other approach that can be used in this way, with using advanced systems, is the links, the text to ontologies. I'm sorry, but we come back on the ontology because at the moment are the core of anything to merge different data. It's possible to be working at using different level of ontology, mesh term, and extract from database the merging the results of a specific level of ontology and a specific level of vocabulary, ontology, and you can retrieve a more restricted way. But at the moment, the two things seems to quite separate. The problem is to develop something to integrate or bridge. For my knowledge, obviously, tomorrow there is something. This is a tool that I hope that you have understood that the knowledge is not fixed. and the concept are not fixed. Then the machine learning and the discovery must be so smart to adapt itself, because they have the capability to, for instance, the real problem, if in a classification process you have a right classification or not, or ambiguous, as I said this morning. But in the wrong classification, you can use, mainly in the case of text, can be considered also elements that are potentially interesting. This is another question: how to screen in a classification process what are the true errors from the possible emerging new concept or exception to a rule. It's not an ambiguity. It's a thing completely, it has a meaning. Or initially one can put into ambiguity, but maintain. It cannot be rejected, because otherwise, if you test the same classification system after 1 year, the knowledge that you use can suggest, can match with some ambiguity and become positive. The problem is how to define, how to discriminate the error from a rule exception. That is a typical problem. That is a problem, mathematical problem to face, because it's difficult to analyze. Officially, a binary classification gives 2 or 3 class classification. You can have 1, 2, 3 classes what you want. But in the error is the management of the error, because in this error can be some information that is enough confirmed by other experiment. If I have only one microarray for a specific gene, this is only one test. You can use it, and probably this will be considered as an error or rejected, considered in its general sense, not directly. Then the problem is there. It's a true error because they are mathematical error, or it could be an exceptional to the general rules that define a class. This is the missing data, for instance, can affect this thing, or the presence of outliers. How do one manage the outlier? It's not so. It's not easy. There are some different options, different possibilities. And in text mining and in the unstructured knowledge discovery, more generally, this problem is increased 10 times more than quantitative data analysis. This is the last consideration about the problem that we have on unstructured data analysis. Thanks a lot. If you have any question, I am here. Text is, but it's the same, working on text.